Alright, so for this one, a volume of 200 milliliters of oxygen is collected over water at 15 degrees Celsius and 700 millimeters of mercury. The total pressure is then increased to 760 millimeters mercury and becomes 100, and the volume becomes 100 milliliters. What's the new temperature? So you see we've got clearly two different sets of conditions going on here. We've got this set of conditions and this one, so we're going to get P1V1 over T1 equals P2V2 over T2. So as we've been doing, we'll set this up P1 V1 T1, P2 V2 and T2. And what we'll do first is we'll look at this as being our first set of conditions, because we can see the answer is going to be over here. We're looking for temperature. So we're going to have this set of conditions. They're all together. 200 milliliters of oxygen, collected over water at 15 degrees Celsius, 700 millimeters of mercury. So we've got our pressure here. Now the pressure is 700 millimeters of mercury, but it's collected over water. So what that means is I'm going to have to go and hunt down my pressure on the vapor pressure chart at 15 degrees Celsius, because that's our temperature, and you can see that the pressure of water here is going to be 12.8 millimeters of mercury. So as I've done in the past, what I'm going to do is subtract out 12.8 millimeters of mercury, and that's going to be the vapor pressure of water. That's going to give me the vapor pressure of my dry gas, which is 687 millimeters of mercury. Now, along with the significant figures here, we've got 0 decimal places, 1 decimal place, so this comes out to 0 decimal places. I have to figure that out before I do this stuff, because this is all subtraction and the other stuff was division and multiplication. So I have to get that going here. 0 decimal places, 0 decimal places. This comes out to 0 decimal places as well. Volume 200 milliliters. Temperature 1, 15 degrees Celsius, plus 273, and that's going to be 288 K. Alright, the pressure here, new pressure, is 760 millimeters of mercury. The new volume is 100 milliliters. Alright, now we're in a position to be able to go ahead and solve for T2. So we're using our equation here, P1V1 over T1 equals P2V2 over T2. Now we have to isolate T2. Now what we can do here is just do an algebraic manipulation here and just flip everything. T1V1 T1 over P1V1 equals T2 over P2V2. So all I've done there is just flip this over and flip this over and flip this over, and that's allowed under these circumstances. Now the next thing I want to do is isolate T2, and T2 equals T1 P2 V2 over P1 V1. Alright, so all I've done here is just shifted this up here and shifted this up here as well. And I'm allowed to do that. I'm just multiplying both sides by P2 V2, and that allows me to isolate T2. Alright, so T2 equals T1, which is 288K, P2, which is 760 millimeters of mercury. Again, notice the importance of using the units here. We've got V2, which is 100 milliliters. And we need P1, which is 687 millimeters of mercury. And we've got V2, which is 200 milliliters. And when all said and done, we're going to get an answer of 159K, which is going to have 3 significant figures, because everything here has 3 significant figures as well. Alright.